managing performance in a hybrid SPA. I am assuming people here are aware of web applications and the differences between server-side rendering and single-page applications. So in the interest of time, I'll move on. So first, about Freshservice. Freshservice is a modern IT service and operations management platform which enables IT team to help their employees for ticket resolution, asset inventory, etc. Like any other startups, we also started as a monolith with server-side rendering. Our primary tech stack involved Ruby on Rails. So for those of you who are aware, Rails provides its own version of static assets management, which is called the asset pipeline. So we were using that and to compile our static assets and use CDN to deliver them faster to the customers at their edge locations. Now, over the years, as the application has scaled, now we are serving close to 150K RPM even at low traffic hours. So our systems needed to scale, right? With the backend, we were able to scale faster with platform services or microservices, etc. But the front end really kind of took a back seat there. And over time, we realized that we were lagging behind there, and it was causing productivity loss, frustrations to the end users, etc. So we started on a journey to move towards a more progressive, modern framework. We chose Ember at the organization level. So every product within FreshWorks sort of uses Ember.js for their main applications. We also use React and Vue for some of the smaller things, but Ember is our primary web framework. So with Ember, you get the build task, which we use for building the static assets, and again we host them also on CDN for faster content delivery. Why does UX matter, right? User experience. So in 2018, there was a study by TopTel which mentioned that 88% of your customers are less likely to return if they have a bad experience. And this was in 2018. So I'm pretty sure the number is now north of 90%. And user experience in today's world plays a very, very important role. So you have to ensure the best performance and experience for your end users, right? This is one of our earlier slides where this page is completely rendered on server side. It's the dashboard view wherein a customer comes in and looks at all the things that are more important to him at that given point in time. And this is our newer version. Now, if you compare, I think there's a little, with the projector, I think the lighting is a little bit off, but the experience was much smoother. We leveraged the white spaces better. The color schemes, the consistency was much better from the previous experience. This is our older ticket details view, wherein the customer usually, they work on tickets. So this was how it looked earlier, and with the newer version, you can see the more important details are well set up at the top. There is also, prominently details are visible to the customer so that they can take the right action with the right amount of data, right information at their fingertips. So why did we go through this exercise, right? From an application point of view, it made sense because as I mentioned, our scales increased gradually over the years, and the application had to scale from the front end perspective. People were writing scattered code here and there. That's usually a fallacy with the server-side rendering applications. People just inject inline JavaScript, CSS, etc. So it led to problems wherein script from one page would break things in another page. So we also wanted our experience to be robust, and at the same time we wanted it to be consistent. With progressive web frameworks, it allows us to define components and the styles for them, so they are actually very consistent across the application instead of them being inconsistent in silos. From an end user perspective, why it mattered was now this experience is more accessible. As you know, for our target customers, accessibility actually plays a key role, and in today's world we wanted to be inclusive, so we sort of started working towards accessibility as a first principle. it also made the user experience improve, right? So customers got better experience out of the new UIs, and it also became reliable because there were fewer bugs that were leaking from different pages. So the core part, right? Why we'll have to focus on performance, obviously, because with SPAs usually with a lot of API back and forth, there is a hit on performance at times. So how did we solve those, right? We used 4 important approaches. So I'll quickly talk about each one of them. The first concept is the data version header. As I mentioned, Freshservice is actually a SaaS application, so we have multiple customers using the same platform. All of their data sort of share the infrastructure, including the database, the cache, etc. So each customer can have its own list of users. They can have their own list of user groups, applications, automations, or all of the other things, right? They can be on different plans. Their plans will give them a set of features. So all of this information needs to be available to the Ember application as well, so that we can take the right decision to render the data accordingly. So we used a custom header called X account data version. This will basically tell Ember that hey, this is the version of the account state currently, and if there is any modification to that state, we will change that header in the successive API calls. This header is actually derived from by getting a unique version across each of these resources and then combining them to generate a secure hash. And we render this account data version as part of every API request that get rendered to Ember. So the second approach that we took was service workers. I am not sure if guys have come across service workers, but it's basically a browser technology which allows you to intercept network requests from the browser to the server. It allows you to do things like, if network connectivity is unavailable, handle those and progressively render the application. So primarily there are 3, you can also use it as a cache on the browser end. So primarily there are 3 steps to service workers. The first step is registration, the second one would be activation, and then the third one is destruction, right? So during registration we tell our service workers to hey, take a note of this account data version, and if there is a change in it, refetch all of the API configurations from the backend and update the latest state on the Ember pages. So that's with respect to service workers. The third, this is a fairly common practice wherein we've started caching our API responses that do not change over time. Like a lot of the configuration data that I spoke about earlier, they don't change regularly, right? Like a transactional data, for example, like tickets, wherein you will keep getting tickets every minute or every hour. But transactional data, configuration data like users or their plans don't frequently change. So we started versioning, caching these APIs as well on the backend. Basically the request comes to our app server. We will look into the cache if the data already resides there. Otherwise we will compute the API and then cache it in memcache, so that next time the same request comes in, we don't recompute all of that data. And the strategy that we used to uniquely identify cached data was, we will have a local version. We will also respect the current agents logged in locale. Because we are a SaaS product, we sort of offer the product works in multiple languages. So we also have to respect users logged in users locale. So that's part of the cache key. We then use the data version of that resource, as I already mentioned, and then the request context. So these things are baked into the API, the cache key, and whenever a request comes into the API server, we first look up if the content exists in memcache. Otherwise, we build it again and then cache it for future uses. And as an obvious performance benefit to that, we notice the response times to fall drastically, right, after we ship these changes. And the final approach was using e-tags. E-tags is basically a RFC standard for HTTP, wherein you could basically version or tag your APIs. basically what happens is, there is when the server responds with the API data, it will also attach a tag to it, which will represent the state of that API at that given point in time. So the next time the browser makes the same request, it'll attach that along with a custom header called if none match, and pass the version that it retrieved from the previous request, from the previous response. Sorry. So if when the server gets this header if none matched, it will try to get the version that was passed from the browser and compare if the version on the server is the same. If it is the same, it will basically render with a 304 not modified, telling the browser that hey, your data is still fresh. I don't need to give you an updated version of it. But if the data has changed, it will recompute the data and then render back to the browser with the newer E tag. Now E tags come in two forms. One is the weak E tag, the other is a strong E tag. Weak E tag is usually prepended with a W at the beginning, W slash, and the value of the E tag, right? It will be a representation of the API, but it will not tie to the actual data of the API. Whereas in case of a strong E tag, it is usually computed on top of the API data itself, right? Now, when you think about it, there might not be a big difference between the two, but the major performance benefit with using weak E tag is, if the data has not modified, right, the server does not have to recompute just to find the actual version of the API. If you use a strong E tag, you will have to actually recompute the entire API response and then match the version. Thereby, you might not save a lot on network bandwidth. You might not save a lot on server bandwidth, but you will save on just the network bandwidth. So we primarily use E tags for saving both network as well as server bandwidths. And once we went live with this, we noticed that more than 50% of the requests that were coming to our servers were rendered with 304 not modified, which saved a lot of critical CPU and network bandwidth for us. This was time spent on doing other important things, right? Now, one of the core questions would be, hey, you've spoken about 4 different technologies, but it's a lot of maintenance overhead to manage all of those separately. So how do they work together, right? They have to work together well for them to function, in sync. So this is like a typical flow that happens when the user first lands on the application. They open the browser and visit their account on Freshservice. We will make a request to our backend server to get the version of the the account, and then register that on service worker. Once that registration happens, service worker will start fetching the configuration data for that account and cache it on the front end. Post which the browser will then continue rendering the actual transactional data, which in this case could be a dashboard or a tickets list view, etc. So let me quickly walk you through 2 scenarios where you could see the difference between all of these working together. So in the first scenario, a user lands on the ticket list view. The first step that happens is the service worker, as I mentioned, the service worker will come in. It will register the configuration APIs and E tags. It will set up the API data version at the account level or at the Ember level, and then it will start listening for changes. Now when the application loads, it will load the requested tickets, right? So the tickets list view will basically give the end user a list of tickets. Now from the list of tickets, if the user clicks on one ticket, right, he'll land on the ticket details view. At that point in time, the application will first load the resource, which is basically a ticket here. It will trigger the service worker to detect if there is any data version change. So as I mentioned earlier, all of the API requests will render with the current account data version. So in this case, when we load the ticket details via the ticket details API, the account data version will be responded back to the browser, and our service workers will try to compare that with the version that it has on registered during initialization. Now the service worker will detect there were no changes, so it will be a no operation, and the user will be able to just use the application without any lags. Now in the second scenario, there is just a subtle change, right? The first part remains the same. The user lands on the list view, he navigates to the ticket details, but when the ticket data is given back to the browser, during the transition, say another agent went and added another field to the form, right? Ticket will have multiple fields, and that is part of our data versioning. So if someone goes and adds or modifies the form in between, this account data version now refreshes, right? It tells the browser that, hey, something has changed, why don't you refresh the data? Now when that happens, our service workers will immediately get triggered from the API response, and you can see that the service worker part of it will detect a change and it will trigger the resync. Now when the resync is triggered, there are like a list of APIs that we maintain at service worker level, which is like user information or fields information, plans information, etc. It will trigger a resync for all of these APIs, but because we've only modified the field data, only that API's E tag would have been modified and the others would have responded with a 304. So the fields API would render with a 200, it will respond with a modified version, and the end user will immediately see the new field on their ticket details view. So everything seamlessly will fall into picture because all of them are tied at the end of the day with the same data version. Yeah, so coming back to the original slide from data versioning, as you can see, each of these entities have their own version, which together form the accounts data version. So that's about it from my side.